Implement Inter-VLAN routing. This topology. 4321 router will be R1. Two 2960 switches, S1 and S2, and two PCs. PC-A and PC-B. And connect the router gigabit 001 on router to fast Ethernet 5 on S1 between switches fast Ethernet 1 on both sides. And from S1 to PCA use fast Ethernet 6. And from S2 to PCB use fast Ethernet 18. This is the addressing table, the subinterfaces on the router, the VLAN 10 interfaces on switches, PCA and PCB configurations, all on IPv4. VLAN table with all VLAN specification and on required resources on real app router, Cisco 4221, two switches, 2960, two PCs, console cables, Ethernet cables. Build the network, okay, ready. Cable the network, ready. Configure basic settings for the router. These configurations were made in another previous labs, so I will only configure the host name in the router. Okay, on the router R1 command line interface. Would you like to enter initial configuration dialog? No. Enable configure terminal. Hostname S1. R1. Configure basic settings for each switch. These basic configurations were made in another previous labs, so I will only configure the device name. S1 command line interface, enter, enable, configure terminal, hostname S1, and S2 command line interface, enter, enable, configure terminal, hostname S2. Configure PC hosts. Use the addressing table to configure PCA and PCB. PCA, desktop, IP configuration, and use this 20.3, default gateway 20.1, 192.168.20.3, subnet mask 24, and default gateway 192.168.20.1. PCB, desktop IP configuration 30.3, 192.168, 30.3, subnet mask 24, and default gateway 192.168, 30.1. Very good. And create VLANs and assign switch ports. You will create VLANs as specified in the table above on both switches. Okay, you will use this table, the VLAN table. Create and name the required VLANs on each switch from the table above. Okay, and configure 10, 20, 30, 999, and 1000. Okay, with names, and go to S1. You are on global configuration mode. VLAN 10, name, management. Enter. VLAN 20, name, sales. VLAN 30, name, operations. VLAN 999, name, parking underscore lot. Case sensitive, VLAN 1000, name, native, exit. Okay. S2, command line interface, you are on global configuration mode. VLAN 10, name, management. VLAN 20, name, sales. VLAN 30, name, operations. VLAN 999, name, parking lot, underscore lot. VLAN 1000, name, native, exit. Okay, exit from VLAN configuration mode to go global configuration mode. Okay, S2 VLANs, S1 VLANs. Configure the management interface and default gateway on each switch using the IP address information. Okay, configure this on S1 and S2. Okay, go to S1. This is S1. S1. Global configuration mode. VLAN 10. So interface VLAN 10. Enter. The IP address 10.11. Subnet mask 24. Default gateway 10.1. IP address 192.168.10.11. Subnet mask 24. Okay, and no shutdown to enable the interface. Exit from interface configuration mode. Exit from interface configuration mode, and once you are on global configuration mode, you can set the default gateway. IP default gateway 192.168.10.1. Very good. The same procedure on S2 global configuration mode. Interface VLAN 10. Enter IP address 192.168.10.12. Subnet mask. Enter and shut down to enable the interface. Exit to global configuration mode and set the default gateway. IP default gateway 192.168.10.1. Okay, default gateway. Okay, very nice. Then assign all unused ports on the switch to the parking lot VLAN. Configure them for a static access mode. Okay, what ports are in use on S1? In use 5, 6, and 1. And select all unused ports. Click on S1. Use interface range to select multiple interfaces. 1 is in use, so select from 2 to 4, 5 and 6 in use, comma, Fast Ethernet 7 to 24 and gigabit 0, 1, and 2. Okay. Enter. Configure them for static access mode. Switch port mode access. Assign all unused ports on the switch to the parking lot VLAN. Parking lot VLAN is VLAN 999. Switch port access VLAN 999. Administratively deactivate them. Shut down. Okay, very good. Okay, and you are on interface range configuration mode, exit to go global configuration mode. The same way on S2, what ports are in use on S2? Fast Ethernet 1 and Fast Ethernet 18. And interface range, Fast Ethernet 1 in use, select from 2 to 17. 18 in use and select from 19 to 24 and gigabit 0, 1, and 2. Enter. Switch port mode access. Switch port access to parking lot assigned to parking lot VLAN and VLAN 999 and shut down. Enter. Okay, and exit from interface range configuration mode to global configuration mode. Okay, the interface range command is helpful to accomplish this task. Assign VLANs to the correct switch interfaces. Assign used ports to appropriate VLANs. And configure them for static access mode. Okay, go to VLAN table. Okay, but look at this. PCA is connected to Fast Ethernet 6 on S1. Okay, Fast Ethernet 6 on S1 belongs to VLAN 20 to sales VLAN. Okay, on S1 interface Fast Ethernet 6 switch port mode access. Okay, static access mode. Okay, says configure them for static access mode. So is this switch port mode access, and assign the used ports to appropriate VLAN. In this case, S1 Fast Ethernet 6 belongs to VLAN 20 sales. Switch port access VLAN 20. Okay, exit from interface configuration mode. And now PCB is connected to Fast Ethernet 18 on S2. Look at here, S2 Fast Ethernet 18 belongs to VLAN 30 operations. Okay, click on S2. Interface Fast Ethernet 18. Switch port mode access. Switch port access VLAN 30. Operations VLAN and exit. Verify. For example, on S1, go to privilege exit mode, exit, privilege exit mode, show VLAN brief, show VLAN brief. And now you can see Fast Ethernet 6 is assigned to VLAN 20. All unused ports are assigned to VLAN 999, and 1 and 5 assigned to VLAN 1. Okay, 1 and 5, 1 and 5 are in use, but will be configured later. Okay, on S2, exit, show VLAN brief, enter. Okay, and VLAN 30, fast Ethernet 18, all unused ports to VLAN 999 and fast Ethernet 1 on VLAN 1 for now. I will configure it later. Configure an AO2.1Q trunk between the switches. Okay, this connection. Manually configure trunk interface on fast Ethernet 1 on switch 1 and switch 2. Configure static trunking on interface fast Ethernet 1 on both switches. Okay, for example, go to S1, configure terminal. You are on global configuration mode, and now select interface fast Ethernet 1 and static trunking, switch port mode trunk. Enter. Okay, very good. And set the native VLAN to 1000 on both switches. Okay, switch port trunk native VLAN 1000. And specify VLANs 10, 20, 30, and 1000 are allowed to cross the trunk. Switch port trunk allowed VLAN. Okay, this message is VLAN mismatch. Okay, this side of the trunk, fast Ethernet 1 on S1 is configured with native 1000, but fast Ethernet 1 on S2, the VLAN is 1, so there is a mismatch, a VLAN mismatch. Okay, enter. Okay, again, switch port trunk allowed VLAN. Okay, permit VLANs 10, 20, 30, and 1000 to cross the trunk. Okay. Okay, again, switch port trunk allowed VLAN 10, 20, 30, and 1000. Enter. Okay, very good. Okay, the mismatch again. Don't worry about this. I will fix in the next step. And enter. And verify. Okay, verify at the end because I need to configure S2. S2 fast Ethernet 1. Okay, the same procedure. Configure terminal, interface fast Ethernet 1, switch. Okay, the mismatch again. Switch port mode trunk. Okay, the native switch port trunk native VLAN 1000. Okay, and you will see this message. Okay, once switch port trunk native VLAN 1000 is set, you will see port consistency restored. Okay, so port consistency restored. Enter, and don't forget to allow VLANs 10, 20, 30, and 1000. Switch port trunk allowed VLAN 10, 20, 30, 1000. Enter. And now verify. Exit to go global configuration mode. Exit again to go privilege exit mode and use the following command: show interfaces trunk. Enter. And now you will see fast Ethernet 1 is mode on, is static trunking. The encapsulation is AO2.1Q. The status is a trunking port, and the native VLAN is 1000. The VLANs allowed are 10, 20, 30, and 1000. Okay, very nice. So verify on S1, and to go directly from interface configuration mode to privilege exec mode and show interfaces trunk. Enter. And you can see also Fast Ethernet 1 on S1, this interface, Fast Ethernet 1 on S1, mode on, static trunking, encapsulation, status trunking, native VLAN 1000, allowed VLANs 102030 1000. Very good. Manually configure S1's trunk interface Fast Ethernet 5. Okay, and this interface is the connection to R1 and should be trunk because gigabit 001 on R1 will use sub interfaces. And you need to configure Fast Ethernet 5 as trunk. So configure interface Fast Ethernet 1 with the same trunk parameters as Fast Ethernet 1. Okay, go to S1, configure terminal, interface Fast Ethernet 5, switch port mode trunk, switch port trunk native, switch port trunk native VLAN 1000, set the native VLAN, and the switch port trunk allowed VLAN 10, 20, 30, and 1000, and that's it. Save the running configuration to a startup configuration file. Okay, do this on S1 and on S2. And to go directly from interface configuration mode to privilege exec mode, and copy running -config to startup-config. Enter. Very good. Go to S2. I am on privilege exec mode and copy running config to startup config. Enter. Verify trunking. Okay, go to S1 and show interfaces trunk to verify trunking. Enter. And only Fast Ethernet 1 is present. Only Fast Ethernet 1. Okay, I just configured Fast Ethernet 5 as trunk. With Fast Ethernet 1 only is present show interfaces trunk output because Fast Ethernet 5 is not active because the another side gigabit 001 and router R1 is not activated. So that's why Fast Ethernet 5 is not active. Okay, what happens if gigabit 001 on R1 is down? S1 Fast Ethernet 5 will not be displayed if the gigabit 001 interface status on the router is down. Okay. Configure Inter-VLAN routing on the router. Configure the router. Okay. Activate interface gigabit 001 is necessary on the router. Okay, this is gigabit 001. Go to R1, command line interface, enter. Enable to access privilege exec mode, configure terminal to access global configuration mode, and activate interface gigabit 001. I will do it at the end. I recommend that. Configure sub-interfaces for each VLAN as specified in IP addressing table. All sub-interfaces use AO2.1q encapsulation. Ensure that sub-interfaces for the native VLAN does not have an IP address assigned. Include a description for each sub-interface. Now, go to addressing table and configure all these sub-interfaces. Remember, sub-interface for native VLAN 1000 sub-interface does not have IP address. Okay, and start with this sub-interface, interface gigabit 001.10. Enter. And now set that description. It's only a label description, for example, VLAN 10. Okay, because gigabit 001.10 subinterface belongs to this VLAN. Okay, VLAN 10 management. Okay, you can use another number. Okay, it's not necessary the subinterface number should match the VLAN number. Okay, it can be different, but in this case, it's the same number. Okay, description VLAN 10 and encapsulation dot 1q 10. Okay, this is the encapsulation. Don't forget that, and belongs to VLAN 10. Okay, description was only a label. You can set here any label, any string with the on encapsulation command. You are assigned the VLAN 10 to this subinterface 1.10. Okay, enter and set the IP address 192.168.10.1 subnet mask. IP address 192.168.10.1 subnet mask 24. Okay, and now the next 1.20, 1.20. Description, any description, for example, VLAN 20. Encapsulation. Now assign this subinterface to VLAN 20. .1q20. IP address 20.1. 20.1. Same subnet mask, and now next subinterface 1.30. 1.30. Description 30. Encapsulation 30. IP address 30.1. And the native subinterface 1000. 1.1000. Description native, you can use this description, and no IP address. With the encapsulation, don't forget assign the native VLAN 1000 to this subinterface 1.1000, but it's the native, so you need to add the keyword native 1000 native that encapsulation that 1q 1000 native. And now don't forget, okay, the indicator is red because gigabit 001 on R1 is not activated. Access the physical interface gigabit 001 and no shutdown. To activate, enter, and now you have the green indicator. Verify, go to R1, and to go privilege exit mode. And okay, but wait, the green indicator on both sides. Okay, if it's orange, wait a moment for the green indicators on both sides, and now show IP interface brief, enter. And now you will see the physical interface with no IP address, but subinterfaces. Okay, 1.10, 192.168.10.1, 1.20, 192.168.20.1. Okay, and 1.30, 192.168.30.1, 1.1000, no IP address, but up. All very good. Protocol up, status up. Very nice. Complete the following tests from PCA. Ping from PCA to its default gateway. Okay, go to PCA and verify the configuration, ipconfig. This is my IP address 20.3. My default gateway is 20.1. So ping the default gateway. Ping 192.168.20.1. Success. Ping from PCA to PCB. Okay, PCB IP address is 30.3. Okay, ping to 30.3. Okay, wait a moment and success. Ping from PCA to S2. S2 IP address. What is the IP address of S2? 10.12. 10.12. Okay, from PCA 10.12. Okay, very good. Repeat all pings, success. And now also you can ping S1. S1 IP address is 10.11. Okay, from PCA 10.11. Success. Repeat. Repeat. Success. Complete the following test from PCB. From command prompt on PCB tracer to PCA. Okay, go to PCB, command prompt, tracer to PCA. PCA IP address is 20.3. Okay, from PCB 192.168.20.3 tracer. Now you have two hops. Why two hops? Okay, because PCB ping goes to the router. This is the first hop. Okay, the first hop is the router 30.1, the default gateway. The subinterface on the router. The subinterface on gigabit 001 on the router is the first hop, and the second hop is PCA. So the ping goes first to router, and router redirects to PCA. So PCA is the second hop. Okay, because PCB is placed in another network than PCA. Okay, both are different networks. And PCB is placed on network 192.168.30.0, and PCA is placed on network 192.168.20.0. So this is Inter-VLAN routing. Okay, very nice. What intermediate IP addresses are shown in the results? The tracer output should show two entries in the result. Okay, the tracer output should show two entries in the result. The first hop is R1 gigabit 001.30 interface, which is the gateway address for PCB, and the second hop is PCA's address. Okay, thank you very much.